Last week, actually, we have discussed about number systems, and today we'll move forward and discuss more about these number system conversions, right? We learned about basically 4 number systems. Can anyone remember? So what are the number systems that we have learned? So we learned about binary, then base 2. So what are the other number systems? Binary, only binary. Yes, you can talk. Don't worry.
Decimal.
Yeah, decimal, octal, and hexadecimal. There are 4.
Decimal.
Yes, binary, decimal, and hexadecimal. These are the number systems that you have. So these same number systems you have in your advanced level also. So better you can remember these things for long time. Binary, octal, decimal, hexadecimal, and the conversions. You have it for your advanced level. Not even that, even for some degrees in first semesters, you have these. සමහර උපාධිවල පළවෙනි වසරට තියෙනවා, උසස් පෙළට තියෙනවා. So better you can remember these things for a long time. Right, octal means base 8 and decimal means base 10. Then hexadecimal means base 16. So can you tell me the valid digits of these number systems? Binary, it is 0, 1, 1 only, and octal 0,
0.
0 to 7, yes, correct. Base 10 or decimal, and not 10, no, 10 is not there. 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and hexadecimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So why we are using A, B, C, D, E, F? So what is the reason why we are using A, B, C, D, E, and F? Yes. So what's the reason? මොකක්ද හේතුව A, B, C, D, E, F use කරන්න 16 පාදේ? I need answers from you. Can you cooperate? Shall we do as a team? Hello? Hopefully you can hear me, no? Dinesh, can you hear me?
We can hear you, sir.
Right. Okay. So, okay, one have answered in chat section. Let's go. Because yes, we can't use 11, 12, 13. The reason is this. So if you are using 10 here, you are reusing these symbols. 0 and 1, you are reusing. So, but we need unique symbols. We need unique symbols, not the same symbol. So if you are using 10, 11, we are repeatedly using previous symbols. But to avoid that, to use unique symbols, we are using 0 to 15 as A, B, C, D, E, F. Okay, that's that part we have learned. And then we have converted number systems. We have converted from decimal to other number systems, basically decimal to other number systems. Let me remind you using few examples. Can you convert 14? 14, can you convert 14? You can write this as a question to binary, octal, and hexadecimal. Can you quickly do this? Convert 14 to binary, octal, and hexadecimal. I'll give you 2 minutes. Quickly find the answer. Convert 14 to binary, octal, and hexadecimal. 14 convert කරන්න දෙකේ පාදයට and octal 8 පාදයට and hexadecimal 16 පාදයට. Quickly do this. I'll give you, you can write down this, write down and complete this within 2 minutes. Okay, I got some answers. Binary. Okay. Others? You have 30 seconds. Okay, let's discuss. Right, 14. 14, what you have to do? 14 divide by 2 and write the remainder. 14 පළවෙනි පාර දෙකෙන් බෙදුවම 7යි. 7 remainder is 0. Again divide by 2. 7 divided by 2 is 3 remainder 1. 3 divided by 2 is 1 remainder 1. So the answer is 1110. So how many of you got the correct answer? 1110.
I got the answers.
Right, you got the answer. Good. So others, only one. Only one. Others. So if you have difficulty in converting, please tell me, right? So because maybe this is your first class, fine, can be. This can be your first class. You have never done this related to IT. But in that case, please kindly let me know, then I can help you. I can explain this again, how to do this and all. Right? Even in the chat section, you can question and ask. So I got one question. Right. Okay, then. So can you convert that to octal? Let's convert this to octal. Convert this to octal. And okay. So here we are. You can see the answers. This is the octal one. 14 you divide by 8. It is 1 remainder 6. So then remainder is 6. So 1 remainder 6 means it is 16. Then 16 divided by 14, 0 remainder 14. 0 remainder 14. So answer is, yes, answer is, you can write 0E or you can even write E. Both are okay. 0E is also okay because putting 0 to beginning will not change the value. Right? Putting 0 to beginning will not change the value. Okay. So then write down this special one. So if you have done this.
So why did you put E?
Because you don't have 14 in hexa.
So why did you put E?
Yeah. You don't have 14 in hexadecimal. Yeah. After 9, this is 10, 11, 12, 13. This is 14. 14 is E. Understood? Understood or not?
Thank you, sir. I got it.
Right. Because you don't have 14, right? Literally, you have E. 15 is?
I got it, sir. Thank you.
Right, okay. Okay. Likewise, if anyone
Yeah.
has questions, please ask, right? So then, so write down this one. This is very important. So write down this note. After that, write down the same. Write down the same thing that I am writing. So these two are valid rules. So if assume that you have integer like, okay, 14. 14 is integer. You can add zeros to beginning, it will not change the value. And at the same time, if you have 14.5, so you can add zeros to this 0.5. That will also not change the value. This equal to 14.500. It's equal to 14.50 is equal to 14.5. All are same. This is equal to 0, 14 is equal to 14 equal to 0, 0, 14. All are same. So you can write the example. But in other hand, this is not equal. 140 not equal, sorry, 140 not equal 14. And it is not equal 1400. Other hand, 0.4 is not equal 0.04. So these are some valid points. Finished writing?
Yes, sir.
Right. Okay. Now, right now, let's do this. Let's practice this again and again because this is very important. Can you convert 145? Question. Convert 145 in decimal. 2.
Sir, Padillani, sir.
Which one? You tell, yeah, I mean, that means you cannot hear my voice, or මාව ඇහෙන්නේ නැද්ද නැත්නම් කරන විදිහද? Hello? Hello? මං කියන දේ ඇහෙන්නේ නැද්ද ඔයාලට?
Now it's okay, sir.
No, it's okay, no? Sometimes, yeah, sometimes it might generate, sorry, because of these rainy days, there might be some issues, some disconnections, but don't worry. So I'll make sure to record all these things and share with you, so you can later watch without any interruption, because the recorded version will be more clear. Okay, write down this. Okay, convert this number to binary, octal, and hexa. Quickly do this. Finished? Or not yet? Still doing? Or finished? Finished or not yet? Hello?
Not yet, sir.
Yes, sir.
Not yet, sir.
Okay, let's do. This is how you convert to binary. Basically, if you get this answer, it's correct. So what is the answer? It's 100100001. And the octal one, again, you have to take the same number, 145, and convert this. 145 divided by 8. Let me know if you have not get this answer. If you got any other issue, let me know. Divide by 8 is, what's the value? It is 165 වලට තියෙනවා 48 and then 56 64
8.
remainder 1 and again divide by 8. Again divide by 8 is you have 2 remainder 2. Okay, the answer is 145 divided by 8 is 18, remainder 1. 18 divided by 8 is 2, remainder 2. So answer is 2, 2, 2, 2, 1. Answer is 2, 2, 1 in octal. Okay, so next one, hexadecimal. Hexadecimal, you have to apply the same mechanism, but divide by 16 this time. 16, then value is 9. 9 and remaining, yes, 9. What is the balance? Remain 1. 9 remaining 1. So the answer is 9, 1 in hexadecimal. How many of you got these answers? So let's see the chat section. Yes. How many of you got these answers? Binary, octal, all 3 correct? Or still you are struggling? Still you have problems? All are correct, right? One say all are correct. So let's ask from one. Let me, have you done this? Vishma, you got it? Okay.
Yes, sir.
Right. Let me correct. Okay, you all are doing good. Great. So now, actually, we should learn why these binaries. Binaries because computers, even in the power on switch, you have this symbol. Even in the power on switch, you have 1 and 0. 1, 0 symbol. And we learned that in images also we have binaries. In images we have binaries. We learned that in previous day. If you're not there, please visit and check the video. In Edmodo we have uploaded that. You can check that. So it is in binaries. And I said that last day, numbers, you can feed using numbers. So those are also represented inside the computer in binaries. Letters and all represented in binaries. So one more thing, there's here, let me show one example. this is how data stored in a CD. Right? Those are called pits and lands. Sometimes you have not heard of, but don't worry. These pits are burned areas. You have a thin aluminium layer in a CD. CD එක තියෙන thin aluminium layer එක. Sometimes this is platinum or gold, but unfortunately you might because platinum and gold are expensive and you cannot see in normal market, but still there are platinum and gold layers. And what really happens when you burn? When you give laser light power, the laser light will turn on and it will burn these pits. It will burn these pits. These areas are burned. We call CD burning. CD ka burn වෙනවා කියලා කියනවා. But when you are reading, so you use low power laser light. දැන් අපෝ read කරද්දී අපි use කරන්නේ low power laser light එක. That will not burn. Based on the reflection, we will measure the distance or we will measure whether it is pit or land. Burn වෙච්ච තැනක්ද නැද්ද කියලා බලන්නේ ගිහිල්ලා එන කෝණයෙන් හෝ ගිහිල්ලා එන්න යන කාලය. So that's happening in these are pits and land is this area. Pit means it's burned. Right? So එතකොට 10 වලින් තමයි මේක කරන්නේ. Bulb එක පත්තු වෙනකොට on වෙනකොට burn වෙනවා. Bulb එක නිවෙනකොට off වෙනකොට burn වෙන්නේ නැහැ. So that's what happening. So anyway, we need binaries. So requirement is of binary is very clear. We need binaries, but you can see binaries are lengthy. Here 1, 2, 3, 4, 5, 6, 7, 8 digits. But here in hexadecimal, you have only 2 digits. Same 8-digit number, you can write in 2 digits. So that is the advantage of hexadecimal. That's why computer prefer hexadecimal. And not only that, so it prefer hexadecimal because calculation is very easy. Here to convert decimal number to binary, binary to hexa, it's only few steps. So let me show you one thing. Let's learn one chart. You can write this with me, or you can draw this chart with me. I'm going to draw a table. You can draw this table with me with 4 cells. Okay, can you tell me digits used in octal? What are the digits used in octal? You can't see the table still? This one? So let me stop sharing my screen and revert back. Can you see now? Okay, it's 0 to 7. Yes, 0 to 7. These are the digits. I'm going to write the digits. So first one is 0. Then you have 1, 2, 3, 4, 5, 6, 7. Can you write down the relevant binaries here in this one? 7 means 111. Can you write other binaries? 7 means 111. How 7 is 111? Because 7 divided by 2 is equal to 3 remainder 1. 3 remainder 1. 7 divided by 2 is 3 remainder 1. 3 divided by 2 is equal to 1 remainder 1. It is, therefore it is 111. Here 111. Can you write the other binaries quickly? Can you fill the other binaries quickly?
Okay, sir.
Okay, sir.
Okay, sir.
Okay, sir.
Okay, I got the answers, right? Okay, good. So all of you have same 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. And so these are the numbers. So this most probably you have taken by dividing. You have taken by dividing. For example, let's do one 4. 4 divided by 2 is 2. 2 remainder 0. 2 divided by 2 is 1 remainder 0. So it is 1, 0, 0. 4 means 1, 0, 0. Let's say 5. 2 remainder 1. 2 divided by 2 is 1 remainder 0. It's 1, 0, 1. Okay. All of you got these answers?
Yes, sir.
Yeah. This is when we
Yes, sir.
yes. Any question? Right. This is similar to sometimes truth table. You have not yet learned maybe, but in future you will be learning this. There's something called truth table in logic gates. Still we have not studied that chapter. It is in the next chapter. We will learn in that one as well. How to draw a truth table is quite similar to this one. But this is not a truth table. This is quite similar. Okay. So most important thing is there's a pattern. Most important thing is there's a pattern. How many of you identified the pattern?